Know who Yogi Berra was? Anybody know who he was? Alright. He was a baseball player for the New York Yankees. He won a lot of World Series when he was on the team. But he also had this uncanny ability to make statements that were kind of funny, unique. He made a lot of statements like this. Chapter 9, notes. Transformation geometry is what we're going to cover today. So our objective is to transform figures using translations, rotations, reflections, and guide reflections. Today we'll be covering translations and rotations. So a strategy for this chapter is to use symmetry. Okay. Somebody tell me what symmetry is in their own words. What's symmetry? Any ideas? Shatis?
It's equal on both sides.
Yeah, it's the same. It's a mirror image. If one side is exactly the same, we divide it down the line of symmetry. One side is exactly the same as the other. So we're going to use that idea in this chapter. So here's the initial problem. Houses A and B are connected to a television cable line L at a transformer at some point P. Where should P be located so that the sum of the distances of AP plus PB is as small as possible? Alright? So, we have to figure out where to put P on that line. And we will learn through what we do today, this chapter, we will learn where that point P should be. Section 9.1, isometries and congruence. First term is transformation. A transformation is a one-to-one correspondence that assigns every point A in a plane to another point A prime. The point A prime is called the image of A, and A is called the pre-image. So the initial point is the pre-image, right? And then when you change the point to the new, you assign the point to a new location, that's the image. Directed line segment. A line segment where one end of the segment has been designated by a arrowhead also called a vector. Which has distance designated by the length of the segment and direction. Indicated by the measure of the angle the vector makes with the positive x-axis. So it has both magnitude, distance, and direction, a vector. A translation or slide, when you slide a figure over, keep it the same size and shape and slide it over, is a transformation in which a vector B assigns to every point A in a plane a point A prime with a distance and direction determined by B. In other words, all the points of the plane slide the same distance and direction. Such a vector is denoted AA prime. Example 9.1. Describe the image of triangle ABC under the translation determined by the vector V in figure 9.2a. Alright, so what this basically says, what we're going to do, so you're given that vector, you would keep its distance and direction, but you would add it to each of these points. So at point B, we'd put on a vector V, and we do the same thing at C. We would add the same distance, direction. There's the vector, and then point A, we would also do a vector V, and then I would have my new triangle A prime, B prime, C prime. I've translated it, I've slid it over using that vector. The next page is a more clear example, better drawn example. So you take the point, each point the same distance and direction, and you see the result. The translation that is determined by a vector V forms a parallelogram A, B, B prime, A prime. Okay, so we have this translation. You can see that they're talking about this, it forms a parallelogram. That's a parallelogram they're talking about. Because A prime A and B B prime are congruent and parallel. Therefore, AB is congruent to A prime B prime, because they're opposite sides of a parallelogram. So this is just a proof that the second figure is the same size and shape. In a similar manner, BC is congruent to B prime C prime, and AC is congruent to A prime C prime. Thus, triangle ABC is congruent to triangle A prime B prime C prime by side, side, side congruence. Then by CP, all the angles are congruent. Any questions? All right. So then we have translations. We have properties of translations. Translations take lines to lines, rays to rays, and line segments to line segments. All right. So if the pre-image was a line, when you do the image, that same, if it was AB, then A prime B prime will also be a line. So translations preserve distance, they preserve angle measure, they preserve perpendicularity, they preserve parallelism. None of those things change from the image to the pre-image to the image when you do a translation. Any questions on the translation? All right. Another important property of transformations is orientation. Triangle ABC is said to have a clockwise orientation if the vertices, when read ABC, are pictured in a clockwise orientation. So if we call this ABC, as I go from each point, I'm going clockwise. So it has a clockwise orientation. Otherwise, the triangle is said to have a counterclockwise orientation. In the figure 9-4, ABC has a clockwise orientation. Triangle DEF has a counterclockwise orientation. Notice that ACB has a counterclockwise orientation. So that a triangle on the left, it can have both a clockwise and counterclockwise orientation depending on how you name it. If you name it ACB, it's got a counterclockwise orientation. Translations preserve orientation of triangles in all their shapes. Alright, so here it's going to take us through step by step how to do a translation graphed on the coordinate system. We have this triangle with vertices negative A, negative 1, 1, B, 4, 2, C, 3, 3, 3, 6. Find the image of triangle ABC under the translation described by the vector. The vector goes 3 over, 2 up. As you can see in A, it's marked 3, 2. So to find the image, A prime, B prime, C prime, I apply that vector to each vertex. Right? So we go from point A here. You can see from point A, when we start at A, we go over 3 and up 2. That's up over 3 and up 2. That's 3, that's 2. That puts us at, you don't have to mark that when you do it, but that's how we get from A to A prime. Over 3, up 2. And then we have our new point, 2, 3. You do that to each point, over 3, up 2. Let's see what you have in your notes. Yeah, so you guys need to do the translation yourself. You can do it on the part D there, or any one of them, the open ones, and you need to translate that triangle. This shows you how to do it. All right? So go ahead and translate that triangle. Yeah, so you should draw the pre-image and the image when you do this translation. Why don't you just have the image? You should You should also have the pre-image on there. So we need to redraw that. All right. We have to verify that triangle ABC is congruent to triangle A prime, B prime, C prime, and that the translation preserves orientation. All right. So we need to find the distances. We find the distance from A to B. We find the distance from A to B. We use the distance formula. So that would be 4 plus 1 squared plus negative 2 minus 1 squared. That equals to radical 34. Right? Now let's see about A prime, B prime. A prime, B prime. I use the points there. So we would have the square root of. Somebody tell me what I would subtract from my x values for this A prime, B prime. Shatis.
7 minus 2.
Yeah, 7 minus 2 squared plus. What would the y values be? Adhesion? 0 minus 3 squared. I square that out, I get radical 34. Alright, so I've shown those two are the same. Right? We do the same thing with BC. So BC is equal to the square root of 3 minus 4 squared plus 6 plus 2 squared, which is equal to radical 65. And B prime C prime is equal to the square root of 6 minus 7 squared plus 8 minus 0 squared, which is going to equal to radical 65. When we do AC, AC is equal to 3 plus 1 squared plus 6 minus 1 squared, which is equal to radical 41. A prime C prime is equal to the square root of 6 minus 2 squared plus 8 minus 3 squared, which is equal to radical 41. So, we have shown each of the sides, corresponding sides, has the same length. Right? So if they have the same length, we can say the triangles are congruent by side, side, side. Because both triangles have a counterclockwise orientation, the translation preserves orientation. Any questions on a translation? Does everybody think they can do it? So let me make clear, because it wasn't clear in the steps there. If they ask you to translate something, you have to have the pre-image drawn. Then you draw the 3 vectors from each point on your pre-image, and then you connect the new points to make your image. All right, you should have all those things in your drawing. Rotations. Another type of transformation is a rotation or turn. A rotation is determined by a point O and a directed angle. A directed angle is an angle where one side is identified as the initial side and the second side is the terminal side. An angle can be directed either clockwise or counterclockwise. In the figure 9.6a, point A is rotated counterclockwise 60 degrees around O to A prime. Here, OA is the initial side of AOA prime, and OA prime is its terminal side. Angles that are directed counterclockwise are assigned a positive measure. Those are positive because just think of the quadrants. You label them 1, 2, and 3 going counterclockwise. So that's why the angles are also positive when you're going counterclockwise. Thus we say the measure of the directed angle AOA prime is 60 degrees. In the figure, point B is rotated clockwise 90 degrees from around O to B prime. So the directed angle BOB prime has a measure negative 90 degrees to indicate its clockwise or rotation. The point A is called the center of rotation in each case. Alright, so we have O as the center of rotation. Notice that under these rotations, OA and OA prime are equal. They don't look like it, but they should be the same length. And BO and BO prime are also the same length. Also, the orientation of a directed angle is indicated by the way the angle is named. For example, the directed angle AOA prime is directed counterclockwise, hence is positive, where the directed angle A prime OA is clockwise, hence it is a measure of negative 60. Questions? Alright. So, we have here, based upon directions based on the directed angles in figure 9.6, we can state the following formal definition of a rotation. The image of a point X under the rotation determined by the directed angle AOB is the point X prime. Alright, so we have the AOB is just giving you the angle, right? And then you apply that angle to OX, and you end up with OX equaling OX prime, and XOX prime is equal to AOB, angle AOB, as directed angles. Let's do an example a little bit more clear. So we have a fixed point a fixed point is a point A under a transformation if A and its image A prime are the same point. The center O of rotation always corresponds to itself. Then we have the identity transformation is a transformation that leaves all points fixed. Transformation leaves all points fixed. So we have this example here. We've got describe the image of A, B, C under the rotation with center O and directed angle X, O, X prime as shown. In the figure. Alright, so what happens, this is how you do this. So this is where, we get into how this what happens here. You're going to have to use your protractor. So what you do is you draw a line from O to C. So you draw the line from O to C, and then with your protractor, you're going to measure on the line OC. It says it's we're rotating counterclockwise, so we measure 50 degrees over to from the line OC. We measure 50 degrees, and then I make the new line, OC prime, the same length as OC was. So there's C prime. Those two lines are the same length. And I've rotated it at 50 degrees. That's how you transform one of the points. We're just going to do a point C on this slide. We'll do the rest down below. Does everybody get how to rotate from C to C prime? Any questions? All right. So if we do that for each point, right? So they do, the angle X prime is 50 degrees. Then we would draw to find where B prime is. We would draw OB, right? Then we would rotate it 50 degrees. And then I would measure it the same length as OB, and I would draw in OB prime. That's how I get B prime, right? We've already done C. To do the same thing for A. You go from the line OA. You rotate 50 degrees. And then you measure OA. And then you go to your new vector there that you just found, and you duplicate OA prime. You do that for every segment. And then you end up with A prime, B prime, C prime. The same as ACB. Any questions? Everybody get what's going on here with rotations? Everybody think they can do one? Raise your hand if you don't, it's not clear. All right. So you've got to show all that when you do your rotation. You can't just you can't just have this out in space. Come on. You can't just have this triangle out in space and then draw another triangle over here with none of this stuff in here, right? you won't get credit, right? You got to draw all these lines. So, properties of rotations. Rotations take lines to lines, rays to rays, and line segments to line segments. They preserve distance. They preserve angle measure. They preserve perpendicularity. They preserve parallelism. So basically, it has the same characteristics as a translation. And those are true-false type questions. All these characteristics. All right, any questions on translations or rotations as far as transformations go? No questions on either of those. Okay, then go ahead